Welcome to the bonus video on the 2019 Part 6 BI synthesis. As usual, the first thing I do when I see this is try to figure out what exactly has happened. So we have added an OH on that position, and we have also done some kind of elimination reaction. So our second step is to figure out the order that we want to do this. I'm going to lean toward doing the elimination first, because if we add OH, well, we've just seen that become a good leaving group and seen that lead to elimination before. So I don't want any kind of like side reactions going on. So let's start out with elimination. In order to cause elimination on this though, I'm going to need to make it somewhat reactive. I need a leaving group somewhere. You can pick your favorite radical reaction and pick your favorite position here, because radicalizing pretty much anything here is going to work. I'm going to use my favorite, which is NBS, and that's going to very selectively radicalize the tertiary position. If you used chlorine and did something on the outside, totally fine too. All right, so then I need to do an elimination reaction, so I need some kind of strong base. This is a tertiary carbon, so I don't really have to be worried about any like side SN2 reactions, so you can kind of do whatever you want here. I'm going to use sodium hydroxide. Nothing fancy. That sodium hydroxide is going to pick off one of the protons. Let's pick off the one up here, just so that it matches the diagram. But any of these are going to work. You do not have to show this. There are not marks for this. I'm showing it for explanatory purposes. All right, so that's what we come out with now. And now what we need to do is we need to add some hydroxyl somewhere. All right, so we need one of those two positions to be reactive. So we need a leaving group attached to it. And just like before, there's only one way that we can really add a leaving group to this, and that's some kind of radical reaction. And also, just like before, you can do pretty much anything you want here. Because this far upper left position, this is a vanillic position. This is terribly unstable for any kind of radical reaction. You don't even have a proton on your central carbon there, so that's not going to be any radical reaction. So do whatever you want. I'm going to use NBS again. And when we do that, we're going to get, oops, classic mistake. We're going to get our bromine on that position. Now, yes, it could also go on the bottom position, but those are the same position based on symmetry, so that's totally fine. Okay, so now all we need to do is do some kind of substitution reaction. This is a primary carbon. It could be allylic, but it doesn't matter. Even if we did an SN1 reaction, we'd still get the same product. But I like SN2 a little better, so I'm going to just dump in some more sodium hydroxide. Just like before. Pow! This time, SN2. And we come out with that as our final product. Just going to label this as E2, just in case that wasn't clear. All right, I hope that was helpful. Good luck on the rest of your studying.